Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogber Jr., your math tutor, and in my today's video, I will be looking at differential equations, and I will be looking at the variable separable method. And under the variable separable method, I'm looking at the second type of problems that we have uh, under variable separable method. So in the first previous problems, we did variable separable method involving problems that we can easily separate the variables. But in this type now, we want to look at cases wherein the variables cannot easily be separated at the first look of the problem. So we have to reduce it to variable separable problems. So let's see how we can look at few problems involving reducible to variable separable type 2 under solving first degree differential equation using variable separable. So now what we need to do is that we need to substitute the most, let's say, the inner portion of this expression, the inner portion of this, to some other variables. Like we represent this whole thing with some variable t or some variable u or some variable v, and then we differentiate that variable. Now we want to consider that variable as a new a function. So we will have two functions now in the problem, but with one independent variable, that is x. So we want to have y plus the other variable as a two functions variable in the problem. So we can say let u equals to 4x plus y plus 1. So u now is the new function. So we must differentiate this du with respect to dx is equals to 4 plus, now since y is another function, so we attach dy by dx. This is 0. So the next target, after we have substituted this portion with some u, the next thing we need to do, we need to solve for dy by dx, from this new equation that we've gotten. So we solve for dy by dx. So du all over dx minus 4 is equal to dy by dx. So wheresoever we see dy by dx, we're going to replace it with du by dx minus 4. So this is now du by dx minus 4 for this equals, now this entire expression was u raised to some power 2. So we can now separate the variables. So we have du all over dx equals to u squared. We send this 4 across, it becomes positive 4. So this now will be du equals, now we cross multiply, u squared plus 4 times dx. Now this is u and this is x, so we need x here, right? So we can divide all sides by u squared plus 4, u squared plus 4. So this and this go out. Now the variables have been separated, so we can integrate both sides. U squared plus 4 equals the integral of dx. Now this u squared plus 4 appears in the form of the integral of dx all over x squared plus a squared, that is equal to 1 over a tangent inverse of x over a plus some arbitrary constant c. So our a in this case now is just 2, and then 2 is raised to the power of 2. So this would just give us 1 over 2, which is 1 over a tangent inverse of, what is it? X now is our u, all over a is just 2, equals the integral of the x is just x plus c. So we can multiply all sides by 2 to get rid of this 2. So we have tangent inverse of u over 2. Now this u now can just be replaced with its expression, which is 4x plus y plus 1, and then all equals to 2x plus, now this should be 2c, but 2c we will still replace it with another arbitrary constant. So we just say arbitrary constant c. So we want to get rid of this. Now you can call this your final answer, but we want to further simplify this. So we know that tangent inverse of x is just equal to x. So therefore we can take tangent on both sides. So tangent inverse of 4x plus y plus 1 all over 2. Then we take tangent on the other side, tangent of 2x plus c. So tangent inverse of this expression is just equal to this expression, which is 4x plus y plus 1 all over 2 is equal to tangent of 2x plus c. So we can just cross multiply. So we have 4x plus y plus 1 is equal to 2 tangent of 2x plus c. So this is how we find the general solution of the differential equation using type 2 of variable separable, that is reducible to variable separable. So thanks all so much for watching. Please don't forget to subscribe to our channel. Please don't forget, do it now, please. Subscribe. See you next video.